can identify arithmetic and geometric sequences on three. 1, 2, 3. I can identify arithmetic and geometric sequences. So today we're still within the spectrum of two-variable equations, but we're moving on to sequences. And sequences, by the word, I mean you are thinking about something that follows something else. And that's pretty much what we're going to be looking at today. It's fairly straightforward, but there's one of them, of the examples that I'm going to go over, has to do with memorizing some formulas. So that might take us a little bit more time than the other. Okay? So, arithmetic and geometric sequences, those go in the center of your fair model. What are they? Here goes the definition. Arithmetic and geometric sequences. They are a list of numbers. What are they, the sequences? Arithmetic and geometric sequences, they are a list of numbers. In parentheses, each number is known as a term. Once again, what are they? A list of numbers, and each number is known as a term. What else? That often form a pattern. So a list of numbers that form a pattern. And what is a pattern called? It's known as a common difference or a common ratio. And I'll show you that in a little bit. So the definition, full definition again for arithmetic and geometric sequences is a list of numbers, parentheses, each number is known as a term, that often form a pattern. And the pattern is known as a common difference or a common ratio. And I'll show you what each one of those means. Examples. I'm going to give you two sets of lists of numbers. Here's the first one. 1, 5, 9, 13, 17, 21. And then the second list of numbers is 1, 5, 25, 125, and 625. Copy those. All right, so let me go over the examples with our definition to make sure that we understand what we're looking at. Okay, writing your utensils down, look up to the screen. You'll finish copying right now. There it goes. It says, arithmetic and geometric sequences are lists of numbers. Do we have lists of numbers here? Yes, we have two of them. Okay. In parentheses, it says each number is known as a term. Question, on the first list of numbers, how many terms do we have? 6 terms. How about on the second one? 5 different terms. Are we there so far? Julian, focus, please. Now, it says that arithmetic and geometric sequences are a list of numbers that often have or form a pattern. So watch. Look up to the screen. Here it goes. I'm going to look at the first list of numbers. I want to see what pattern do they have. Tell your neighbor what's happening from one number to the other. Who sees that they're adding 4 all the way through from one number to the next? Is there any break in the pattern? No, it's consistent. So they're adding 4. When they add or they're adding a negative or adding a positive to a sequence, that's what we call an arithmetic sequence. What is it called? Arithmetic sequence when we add a positive or add a negative consistently all the way through. Now, that pattern, right now the pattern that we found is +4, right? When it's in an arithmetic sequence, that's what we call a common difference. And instead of writing just +4, we label this as letter D. Does everybody know why it's labeled letter D? Because it's what? Difference. That lets us know that it's part of the geometric sequence. Are we there so far? I'm sorry, arithmetic sequence. Now check this out. So we're done with this one. Let me go to the next one. Tell your neighbor what's happening from there to there. It's doing what? Multiplying times 5 on this one. Whenever you find a sequence that it's consistent all the way through, multiplying times an integer or multiplying times a fraction. That's what we call a geometric sequence. And if it's multiplying all the way through, that's what we call the common ratio. So guess what letter I'm going to label this pattern? That is correct. R for ratio. This one for difference. This one for ratio. Copy that, please. You have your colored pens. Make sure you use your colored pens for that. Okay, did everybody copy the non-example? All right. So here we go. Look at the non-example. Now for the other two, for the other two, did we find a pattern for the top one? Yes, and we found out that it was an arithmetic sequence because they're adding all the way through. The second one, we found a pattern which was multiplying all the way through. That's why we called it the what? Geometric sequence. So now we arrive here at this one. Oh, sorry. At this one. See if we can find a pattern all the way through. Talk it over to your neighbors, see if they found one. I heard first plus 2. Is that correct? What else? And then this one times 2. Let's see if it works. Let's add 2 to this one. Does that give us 8? Yes. And then let's multiply this one times 2. Does that give us 16? Yes. Plus 2 times 2. However, is it addition all the way through? Is it multiplication all the way through? That's why this one is neither arithmetic or geometric. You understand the difference? All right. So copy that, and then I want you to come up some hashtags in regards to what makes arithmetic and geometric sequences so specific. Hashtag what? Julian, give me one. Pattern. Okay. What would be another hashtag? Alien. Arithmetic. Sequence. What else? Jason? Geometric sequence. Okay, but what makes those? Hashtag what? Luca. What is it? Hashtag list. List of what? Of numbers. Okay. One last one, Fatima. Hashtag common difference. And of course the last one would be what, everyone? Common ratio. All right, let's move on. Here are some steps that we're going to look at for explicit rule and recursive rule. Later on, you can copy those from the video. I'm already making the video so you can look at those later, but I want to get to the practice so you can see the steps in action, okay? So here we go. So today we're going to look at two different types of rules, something what we call explicit rule and the other one that's called recursive rule. Let me go to explicit rule. Copy this one, please. Example 1Q. Right now we're focusing on which rule? Explicit rule. Okay. And it says, find the first four terms of the sequence defined by the function f of n equals n squared plus 1. If you notice, this is very similar to one that we did yesterday in the lesson in regards to, remember that it said Bree worked so many hours, and they give us the function f of x equals 5x. You guys remember that one? Yes? No? Yes? And then we substituted values in the table and so on and so forth. So check this out. So when we get to these, this one's called Explicit Rule, because all we have to do is use the rule that they give us explicitly for what they're asking us for. So watch. If they want us to find the first four terms of the sequence defined by this, then we need to make a table. There we go. I'm going to make a table over here. However, instead of x, what do I have now? N. And instead of y, what do I have? F of n. And how many terms do they want us to find? First four. So I'm going to do 1, 2, 3, 4. And watch. This is called explicit because it's fairly straightforward. It's very explicit into what to do. Stay focused, please. Here it goes. I'm going to substitute the first value, which is what? 1 in here. So I'm going to write what? F of 1 equals 1 squared plus 1. F of 1 equals, what is 1 squared? 1 plus 1. What is 1 plus 1? 2, and that goes right there. Is it straightforward? Yeah, that's what we call explicit, being explicit in regards to the rule that they give us. Let's go to the next one. 2. So I write what? F of 2 equals 2 squared plus 1. F of 2 equals, what is 2 squared? 4 plus 1. What is 4 plus 1? 5. And that goes right there. Start copying that, and we're going to do the rest by, together. Next. What's my next term? The third term. So I write what? F of 3 equals 3 squared plus 1. F of 3 equals 9 plus 1. What is 9 plus 1? 10, and that goes right there. And I want you to do the last one by yourself. Do F of 4. Second all done? Okay. So, let's see. Who did this? F of 4 equals 4 squared plus 1. F of 4 equals 16 plus 1. What is 16 plus 1? 17. Hands if you got that. Is it straightforward? Yes. So that's why the explicit rule, I believe, is probably the easiest one that we can think of. Okay? Why is it called explicit? Because the rule, they give us the rule every time. And every time might be a different rule. So this was example 1Q. So look at the next example. Look up. Look at this explicit rule. Is it different from the previous one? Yes, but can we make a table also for this one? Yes? All right, so I want you to copy this one, example super Q. You don't have to copy the instructions anymore, but they want the first four terms. F of n equals 3n plus 1. I want you to do a table for that and find me the first four terms. Copy that and go. Okay, let's see who did this. N, F of n. 1, 2, 3, 4. So far so good? All right. So I start with the first one. So you should have done f of 1 equals 3 times 1 plus 1. F of 1 equals, what is 3 times 1? 3 plus 1. What is 3 plus 1? 4. Hands if you got that. Okay, good. Next, f of 2 equals 3 times 2 plus 1. F of 2 equals 6 plus 1. What is 6 plus 1? 7. Hands if you got that. Okay. So far so good, right? Next, this one. F of 3 equals 3 times 3 plus 1. F of 3 equals 9 plus 1. What is 9 plus 1? 10. And lastly, f of 4 equals 3 times 4 plus 1. F of 4 equals 12 plus 1. Therefore, f of 4 equals 13. Hands, have you got that? Any questions with explicit rules? So what do we know about explicit rules? That they're going to give us the rule, and we just need to substitute values to find the terms that they're asking for. Is that correct? All right. Now let's move on and crank it up a notch. Yes? Here it goes. All right. So for this one, before we do the example, I want you to copy where it says arithmetic sequence. Copy that. And copy this one, geometric sequence, side by side. This one, I want you to copy it in blue. And this one, copy it in red. First copy those two. Don't copy the top or anything else. Just copy arithmetic sequence, geometric sequence. It should be on your screen also, right? Copy that. Okay. So, these two sequences are known as, look up to the screen, these two sequences are known as recursive form or recursive sequences. And you're saying, what does that mean? I'm going to show you right now, but this is the title or the name of these two. Now, what's the difference between the explicit? The explicit, they change the rule every time and they give you a new rule for you to find the terms. For these recursive, the formula is always the same. This never changes and this never changes. Everybody understand that so far? And you're saying, okay, now let me show you the commonalities. What are the same on both? If you notice, f of n equals f of n minus 1 is the same for both. So what's the only thing that changes from arithmetic to geometric? The difference and the ratio. You guys see the D and the R. Okay? That's the only thing that changes. So now that you wrote those down, I'm going to go over example 2A. Write your utensils down, you'll copy in a little bit. Here we go. So, if I give you example 2A, I'm going to ask you to find the sixth term. First of all, how many terms do we have here? 1, 2, 3, 4. Are we there so far? Okay. Well, the first thing I need to know is the pattern. Carry near what's happening from one to the other. They're doing what? So we're adding 4 all the way. What is that known as? My letter what? D for difference. So now that I identify that, I go to my formulas. Which one shall I use? This one or this one? This one because it's an arithmetic sequence and that's the one that has the letter D. Are we there so far? So now, check this out. Pay attention, please, or you're going to miss it. They want me to find the sixth term. This form is called recursive because recursive means that I require the previous term of the one they're asking me for. Which one are they asking me for? Oh my goodness. Which one are they asking me for? The sixth term. But I need the fifth. I don't have the fifth. Now I can just use the pattern and find the fifth, but that's not the point. We need to use algebra. So in order for me to find the fifth, the sixth, I first need to find the what? The fifth. So this is what I'm going to do. I'm going to find the fifth term. What do? I substitute 5 into the n. So watch. F of 5 equals f of 5 minus 1 plus, what is d? 4. F of 5 equals, what is 5 minus 1? 4 plus 4. Question. This is the fourth term, right? What is my fourth term? 21. So that goes right there. I bring everything else down. F of 5 equals 21 plus 4. So my fifth term is 25. Let's see if it's true. Add 4. 21 plus 4 is? That is correct. But now I used algebra to find it. Are we there so far? But am I done? No. Which one are they asking me for? Do I have the fifth one now? Yes. So now I go sixth term. And what do I write? F of 6 equals f of 6 minus 1 plus 4. F of 6 equals f of, what is 6 minus 1? 5 plus 4. Question. What is the fifth term? 25. That goes right there. I bring everything else down. F of 6 equals 25 plus 4. Therefore, f of 6 equals 29. Am I done? Yeah, this is my sixth term. Copy that, please. That's what we call recursive, meaning that we require the previous term to the one they asked me for. Copy that. So here goes the process one more time as you're finishing copy. I'm going to give you a sequence. What is the first thing that I did? I numbered the terms. And then I need to look at which one are they going to ask me for, the sixth term. What did I do next? I found the pattern to see if it was a difference or a ratio. What was this one? A difference. That let me know which formula to use, if arithmetic or geometric. So what does that tell us? That we need to memorize these, yes? F of n equals f of n minus 1 plus d, or times r. Once we do that, if they want the sixth term, that means I need to start with the fifth term, substitute values, get that, and move on to the next one. All right? Lastly, look up, please. Let's say I gave you this one. And I ask you for the sixth term. How many terms do they give me? 1, 2, 3, 4. What's the pattern? Times 4. So which formula am I going to use? The geometric. So then if I need the sixth term, but I don't have the fifth one, guess what? I need to do what? F of 5 equals f of 5 minus 1 times, what is r? 4. F of 5 equals f of 5 minus 1, which is f of 4 times 4. F of 5 equals, what is the fourth term, everyone? 64 times 4. F of 5 equals 64 times 4 is 256. And now I can find my sixth term. Is that correct? Same thing, just now with the ratio. Okay. Home plate for tonight is on page 138. Odds only. Now, note, tomorrow I'm picking up a packet of home plates that you owe me. You owe me page 110. Thank you. Page 110. Play sheet 4.2, which was the small one. Remember that one? And play sheet relations and functions, the one you picked up from the printer. Those three I'm picking up tomorrow. And, of course, this one. Have a good one, guys. There is tutoring. If I don't see you guys tomorrow. Bye.